This is another question on linear momentum, and for this question it is a study on water jet, meaning that the pressure that we have at point 1 and point 2 should be equal to 0. So P gauge 1 and P gauge 2 over here should equal to 0, and this one should equal to 0. It means that the whole system is outside a pipe. So water exits from a nozzle is deflected by a vane as shown in figure 4a. So this is the vane, okay, and the diameter of the water, the speed and diameter of the water are 5 meter per second. So the velocity at this point, if you can see from here, it should be uniform, meaning that V1 should be equal to V2. It should be equal to 5 meter per second and 0.005 meter square. Okay, so for this question, it says this is a diameter, but the number is in meter square. So I believe this might be the wrong parameter. It might be the area, because the unit over here is in meter square. So the area, again, this is uniform. We don't see any difference between point 1 and point 2. So we can consider that A1 should be equal to A2 and should be equal to 0.005 meter square. So A1 equals A2 equals 0.005 meter square. If the water is deflected 50 degree, here we have 50 degree, determine the force exerted by the water on the vane. Okay, so for this question, we have water coming out from the nozzle. We already know the velocity for point 1 and point 2. The area is also given, the surface area of liquid, and the liquid is water, so the density of water should be 1000 kilogram per meter cube. Okay, and the question asks us what is the force exerted. So the force over here means we have to find Fr. Okay, the first thing that we need to do is we need to find out what is the mass flow rate, because when we do linear momentum calculation, it requires us to know the mass flow rate. So m dot is equal to density times area times velocity. So it doesn't matter A1 or A2, V1 or V2, because both have the same number. So the calculation should be equal to 1000 times 0.005 multiply 5. So we have mass flow rate should equal to 25 kilogram per second. Okay, so now we can start and do our calculation on linear momentum. So first what we do is we do summation of fx equals to 0, and going to the right is positive. Okay, so this is on the x direction. So what we do here is we check on P1A1. Since P is 0, so P1A1 should be equal to 0. So this is 0 plus P2A2 is also 0, so plus 0, and then we add up Frx over here, assuming it is positive. And then next over here we have mass flow rate, and then we check on V2. V2 is going to the right with an angle of 50 degree. So we have V2 cos 50 degree, and then minus, again this is an operation, check on V1. V1 is a positive direction flow, so we have V1 over here, and if you put in the numbers inside, Frx is equal to mass flow rate 25, V2 is 5 cos 50 minus 5. So the answer for Frx should be equal to negative 44.65. So here negative 44.65 Newton. So Frx is this number. Okay, next we do summation of Fy equals to 0, assuming going to the top is positive, the direction. So for this one, it's the same thing again. P1A1 is 0, P2A2 is 0, so 0 plus 0 minus W, but again for this question we don't have any number for the W, so W should be considered 0 plus FRX, for FRY equals to the mass flow rate, and then once again V2 is going upward, it's positive but with an angle 50 degree, so we have V2 sine 50 degree minus, then at point 1 V1 is not going vertically, so this is totally horizontal, it means we don't have any V element here, so this is equal to 0. Okay, so the FRY, putting the number inside, should be mass flow rate 25, 5 sine 50 degree. This should equal to 95.76 Newton. So we get the number for FRX here and FRY over here. So to find out what is FR, it is equal to 44.65 square plus 95.76 square and the square root of it. Okay, this is negative, so and the answer for FR should equal to 105.65 Newton. So that will be the answer for this question. Next, we will continue with a question on linear momentum in terms of pipe. A part of piping system used to deliver water to a refinery in Taiping power plant is shown in figure question 5A here. Water flows through the pipe band at section A with a velocity of 3.5 meter per second. So here, water is moving in at 3.5 meter per second. So the flow comes in like this. So this should be m dot v1 and this should be m dot v2. So here v1 is equal to 3.5 meter per second and the pressure of 250 kilopascal. So P1 should equal to 250 kilopascal. The reducing pipe band has a 150 mm diameter at section A. So diameter over here should be 150 mm equals to 0.15 meter. And 100 mm diameter at section B. So section B over here should be having instead of 1, this is A. This is also A, this is DA. So this is dB, so equals to 0.1 meter. Neglecting the elevation difference between section A and section B, so this is important. Calculate the following. Number 1, the exit velocity VB. Okay, so this is VA. So this is VA and this is VB. And number 2, the horizontal anchoring force effects needed to hold the band. Okay, so the first thing to do right now is, since we know both of them, it's not open to atmosphere, we need to draw a force or a line or an arrow to provide us with the understanding on the pressure. So here we have PA and PB should be acting inward into the system. So PB. Okay. Now the first thing that we need to do is to find out the important parts in the study. First, we know VA over here, PA and DA. However, on part B or section B, we only know DB, so we need to find what is VB and also what is PB. To find VB, we use continuity equation. To find PB, we use Bernoulli equation. Okay, so in order for us to use Bernoulli equation, first we need to find VB also. Okay, so the first thing to do, we are trying to find what is VB and PB. So to get that, first we need to know what is area at point A. So area at point A is pi 0.15 square over 4. So this is equal to 0.01767. So 0.01767, and then we find the area at point B should equal to pi 0.1 square over 4. So it is equal to 0.007854. Okay, so meter square. Alright, to find out what is VB, so we use continuity equation. QA equals to QB. So AA VA equals to AB VB. So to find out VB, it is equal to AA VA divided by AB. So equals to 0.01767 multiplied by velocity A 3.5 meter per second, then divided by 0.007854. So VB is equal to 7.874 meter per second. Alright, so we solve for VB, so that will be the answer for question 1. Now we will continue and try to find PB over here. So to do that, we have to use Bernoulli equation. So between point A and B, so PA G plus ZA plus VA square over 2G equals to PB G plus ZB plus VB square over 2G. So since ZA and ZB, from the wording here, neglecting the elevation different, so we neglect ZA and ZB, and then we know PA, VA, PB and VB, so we have to find out what is PB here. So we rearrange the equation to be PB equals to PA plus VA square minus VB square divided by 2G, and the whole thing is multiplied by rho G. Okay, getting the number in, PA should be here 250 kilopascal, so 250 K divided by rho, this is water, so 1000 times 9.81 plus VA, which is 3.5 meter per second, minus VB 7.874 square divided by 2 times 9.81. Then the whole calculation here is multiplied by 1000 times 9.81. So PB should equal to, so the answer for the calculation should be 225, 125. So here PB is 225,125 Pascal. So that will be the answer for PB. So from there, we can do the linear momentum calculation. And since the question only asks us about Fx over here, so we only have to find it in terms of x direction. So summation of Fx equals to 0. To the right is positive. Okay. Right, so we have first look on the left side, section A, we have PA, positive to the right. So it will be PA, AA, and then we check on point B, it's going to the left with an angle of 30 degree. So minus PB, AB cos 30 degree plus FRX equals to the mass flow rate. And then we have VB over here going to the right. Okay, so it is positive VB, but with an angle of 30 degree, so cos 30 degree minus VA is going to the right, so it's positive VA over here. Once again, this is an operation, so VA over here is positive. So that's why it becomes VB cos 30 minus VA. So getting the number into the equation, so PA over here is 250K multiplied by the area for A, we have it here, minus PB, which is the one that we get over here, okay, remember the cos 30 degree plus FRX will be equal to the mass flow rate over here. I continue down here. The mass flow rate is rho. Rho for the question is 1000. This is rho AV. So the area, so pick one area that we want so that we can pick the right velocity also. So maybe we can take area A and VA. So area A is 0.01767 multiplied by VA 3.5. Then we have VB cos 30. So VB is 7.874 minus VA, which is 3.5. So FRX is equal to, the number for FRX is 2680, negative 2680.98 Newton. Okay, so what does it mean by that? It means that the FRX is 2680.98 Newton and it is acting to the left. So that will be the final answer for this question.